Welcome to Friendly Math 101. Today's lesson is over. Special right triangles. There are two types of special right triangles. You have the 45, 45, 90 triangle. You also have the 30, 60, 90 triangle. Today we're going to talk about the 45, 45, 90 triangle. This triangle is special because it follows a certain pattern. So first of all, the way I know this is a 45, 45, 90 triangle is because I know if this is 90, this is 45, this has to be 45. Because they all have to add to equal 180. So that would be the only situation where all angles add to 180. So when we have a 45, 45, 90, since we have equal angles, we're also going to have equal sides. So if this is 45, the opposite side is going to be equal to the opposite side of the other 45-degree angle. So these two sides will be equal, and I'm going to call them x. And this is going to be our pattern. So both sides I'm going to call x. The third side I'm going to call that same x times the square root of 2. This is just the way it is. You can use the Pythagorean theorem to prove it, but this is the pattern we're going to memorize because it's easier than using the Pythagorean theorem all the time. Just memorize this pattern. So let's use the pattern to go ahead and do a couple examples. So on the left, my first example here, I'm going to rewrite my pattern up here so I remember it. X, 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 square root of 2. And I'm going to solve for x and for y. So I'm given one side. This is equal to x because it's just that way in the pattern. So x is also going to be equal to that 7 because both sides are equal. So that was easy enough. To get the y is equal to x times the square root of 2. Well, x is 7. We know that here. And we just stick on that square root of 2. You don't actually want to multiply those two together because we want to keep our answer in simplest radical form. We want it to look nice. We don't want a long decimal. So 7 square root of 2 would be your answer. And that's that problem. Moving on to the second problem. So we have our pattern, x, x, x square root of 2. And if you notice, I didn't go over this, but both of these triangles are 45, 45, 90. That's the only reason I can use the pattern. Here I'm given this value, the hypotenuse, and I'm trying to find a side. So this one is not as easy. But if you see what I did over here, this side equals x. Well, the hypotenuse equals x square root of 2. And this side here is equal to x. So if I can find x, then I can find a, or I can find my missing side. So I want to undo what's being done to x. This means x times the square root of 2. To undo multiplication, I divide. And those will 1 out there. When I divide by the square root of 2, I get 20 divided by the square root of 2. Now we cannot have a square root in the denominator, so we want to rationalize, which means we're going to get rid of the square root in the denominator. Now the only way to do that is to multiply by whatever is in the denominator. So I can cancel out the square roots by multiplying it by itself. What you do the bottom, you also have to do the top, which is why I had to multiply by the square root of 2 over the square root of 2. So when I multiply these, you just multiply across. 20 times the square root of 2 is just 20 square root of 2. The square root of 2 times the square root of 2, like I said before, it's going to cancel out the square roots and all you get is a 2. It becomes the square root of 4 and the square root of 4 is 2. Now we can reduce just a little bit more here. I can divide 20 by 2. That's going to leave me with 10 square root of 2. And that would be my answer. Thank you for watching, and for more math tutorials, please subscribe to our channel. Friendly Math 101.